So we're going to go through the solution for drawing the Lewis structure for SO2, which is problem number 5 on the extra practice worksheet. I'm going to start like I've done the last bunch, which is to identify how many valence electrons we have. So we're looking at sulfur and we're looking at oxygen. And in this instance, we have 1 sulfur, times 6 valence electrons. And I've got 2 oxygens times 6 valence electrons, which is 12 valence electrons. Add that up, that is what, 18 valence electrons. So like we've been doing, we always take our central atom, place it in the middle, and we're going to add the oxygens to either side and bond them together with a single bond. And so I've used two single bonds, so that's 4 electrons. So 18 minus 4 is 14 valence electrons. Now, the next step is to go ahead and add pairs of electrons around the remaining atoms until I've used up all of my electrons. So 2, 4, 6, 8, 10, 12, 14. So it looks like both of the oxygens have 8 valence electrons. They have 6 dots and 1 dash. 1 dash is 2 electrons plus 6 dots is 8 valence electrons. So they're both in the best arrangement. However, sulfur is not. Sulfur has 2 dashes and 2 dots, so that's 6 electrons. So sulfur is short. So what that means is that we're going to have to create a double bond. And so what we're going to do is we're going to take one of the pairs of electrons. And for sake of this worksheet, it kind of doesn't matter which side we do it on. So I'm going to create a double bond. I'm just going to clean the structure up a little bit here. So oxygen and sulfur. And we've got the single, double, 2 pairs of electrons here, pair of electrons here, and then 3 pairs of electrons there. And then I've got the double bond here. So now sulfur has 2 dots and 6 dashes. Each dash is 2 electrons. So 2, 4, 6, 8. And all of the other, and then the oxygen on the right has 2 dashes, which is 4 electrons, and 2 dots, which is 4 electrons. So that one has 8. And then the oxygen on the left, still the same. And we're not going to look at the resonance structures here. We're just really focusing on your ability to draw the Lewis structure. So if you have the double bond on the right side or the left side, it doesn't matter in this case. So now we're going to go and identify what the polarity of the bond is. So we're looking at the relationship between sulfur and oxygen. And when we go to the periodic table, we see that sulfur is 2.5 and oxygen is 3.5. So 2.5 and oxygen's 3.5. So hopefully you might recall that that is a difference of 1.0, which means it's a polar bond. We're going to draw the dipole arrow toward the larger electronegativity. So we're going to do this for both bonds, like so. We are going to draw the partial charges. The larger electronegativity gets a delta negative, and the smaller electronegativity gets a delta positive. So that means that both of my oxygens are going to be delta negative, and the sulfur is going to be delta positive. To name this structure, we start with the first element, which in this case is sulfur. I see that there's 2 oxygens, so that tells me I need a prefix of di. It's going to become ox. And so then we're going to drop the oxygen, the gin ending, and add IDE, and it's going to become sulfur dioxide. So that is the solution for problem number 5. Hopefully that helps if you had some questions, and good luck finishing the worksheet.